translation, but we're going to kind of start and look at it from the ribosomal point of view, only because this is the part that kind of gets confusing, right? So, once the mRNA was made and processed, it went from the nucleus to the cytoplasm. Okay. Once the mRNA is in the cytoplasm, what's the first thing that happens? The small, right here, the small subunit, right? So this thing right here, the small subunit goes and sits. So now you have to think there's an mRNA here, right? So this is 5 prime, that's 3 prime. This is my mRNA that's already processed, ready, and went in there. So 5 prime to 3 prime mRNA, the small ribosomal subunit sits in there. Before this large ribosomal, this large subunit comes in, before that one comes in, what has to happen? The tRNA. Not the enzyme. The tRNA with? No. With which amino acid? Methionine. So, the first thing that comes in is the AUG methionine with the attached to the tRNA, right? That's FMET, formal methionine. So once that comes in, then the large subunit sits in there. Okay? Now, the large subunit has 3 sites, the E and the P and A. E is the exit. That's the one that gets the empty tRNA once it has its amino acid detached from it and form the peptide bond, right? Then the P is the peptide and the A is amino. Basically, the new ones coming into the A, the growing peptide chain is on the P, and then the E gets the empty one. So what that looks like, let me go back and show you.
What's the A?
What that looks like is this. Okay? So the E is always the exit. You can see there's no amino acid on this tRNA, right? The tRNA that comes in, the new one comes in into, this is the A site. And then this right here where this is sitting, this is the P site. Okay? So what is the name of each of those sites? The P site is peptidyl, right? Peptide. A site is amino acyl. This is the tRNA site also. And exit site is the where the tRNA is completely empty at that point. It's just the tRNA with the triplet codon. There's no amino acid on that one.
Is this first slide?
Yes.
Do we have to remember those actual names for each site?
No, just know there's an A, P, and E. It doesn't matter that you don't remember it's amino acyl, tRNA, and peptidyl. Yeah.
Is this an all-out DNA translation or is this specific, the initiation, elongation, and termination?
So this is the elongation part. So the part where this happens, right here, okay, this is elongation. So mRNA is there, the small ribosomal subunit has already bound, the large one has bound, there's tRNA, there's a growing polypeptide, just that, all that means is there's amino acid after amino acid after amino acid. Yes.
What's the first amino acid that is sulfur?
Formal methionine, FMET.
FMET starts the...
Okay, FMET is attached to a tRNA that has the anticodon to AUG, so UAC. Okay, so that one will go and bind on the mRNA where it says AUG, right? Because that's always the start point on the mRNA, AUG.
So which is the codon? Which is
the codon is the one that's on the mRNA.
No, like UAC and AUG.
UAC is the anticodon.
Okay.
Yeah. Questions? Okay. So this is what we've already talked about, but quick recap of it. Initiation is where the small ribosomal subunit binds to mRNA. This is all happening in the cytoplasm. The start codon is AUG, methionine. The first one that comes in sits in the P site. Everything else is going to come into the A site. A site recognizes the codon, pairs it with the correct tRNA. The peptide bond, what that is just a bond between the amino acids. And then termination is when you get to any of the stop codons. So it will read 3 codes at a time until it reaches one of these three. Okay, we don't need to memorize it because you're going to be given a table where you can see it on there. Yes.
What about the large?
What about it?
Is it like? Wait, what does it like do?
Well, this whole P site, A site, E site, where is it?
Oh, is it on?
It's on the large ribosomal subunit. Okay? So, you have initiation, right? That's your beginning point. You have the mRNA that went into the cytoplasm. Small ribosomal subunit sits in there. AUG with the tRNA comes in, right? It recognizes the AUG. The first tRNA that binds to it, when the large ribosomal subunit sits on top of that, that first one ends up in the P site of the large ribosomal subunit. Okay? Then every new one that comes in is going to come into the A site. And then once the peptide bond breaks and reforms, a new peptide bond forms, that's going to go into the P site. So once it's empty and it doesn't have anything, it goes into the E site. So E site is a tRNA without any amino acid on there. A site is always the new incoming one, and the P site is the growing polypeptide chain. Yes.
It's like a continuous process,
Right. So it goes three at a time until it reaches one of these. UAA, UAG, or UGA. Once it gets to that point, then there's something called a release factor that comes in. It's just a molecule that will bind and make the whole thing fall apart. So now you have this long chain of amino acids, which is really your protein, but it has to be folded in order for it to be the functional protein. So as it is, bless you, it's not a full functional protein until it goes through all the folding process. No, AUG is on the mRNA.
Would it be then UAC?
Right. So let's look at let me draw this out for you. Okay. So we have the mRNA, right? This is your mRNA. This is your 5' end. This is your 3' end. Okay. mRNA comes into the cytoplasm. The small ribosomal subunit comes and sits here. Okay, so this is the small ribosomal subunit. Okay. On here is AUG on the mRNA. There's a tRNA that has the anticodon to AUG, which would be what? UAC. Okay. This one carries with it formylmethionine. Okay. This one makes these little hydrogen bonds, right? Because that's how bases connect together. Okay. So it comes in hydrogen bonds, then comes in the large ribosomal subunit. Okay. When the large ribosomal subunit sits on there, let me fix that. Hold on, give me 1 second. That wasn't a good one. When the large ribosomal subunit comes and sits on there, this formylmethionine, the first one with the UAC, which has the AUG codon, right? This one ends up in the P site. So this is the P site. There's the A site here, and then the E site here. Okay? All right. So the next 3 codons, which really should align with the A site, right? Let's say it's, I don't know, U, G, G. Okay. So now there is a tRNA, right? That has what? A, C, C with whatever amino acid that is. Okay. It's going to come in and sit here. Okay. Once it sits there, what has to happen is this amino acid and this one have to bind to, and this one have to bind together, right? So now, think about what happened. Let's go on So let's think about what just happened here. You have your mRNA, you have your small, you have your large ribosomal subunit. There was AUG here. This is the E. That's the P. That's the A, right? So there's a tRNA that came and sat in here that has an amino acid. Okay, whatever that was. There's formylmethionine here because that's how we always start. That's it. Your first one is always P site. Everything else that comes in will come into the A site. Okay? Now it has to move. How far does it have to move? It has to go 3 codons to the right? So basically everything has to shift, right? So that this one that broke off and formed a bond here, right? So forms a bond here. Everything shifts over. This empty one goes into here. This one with a 2 now amino acids go into here. And now the A1 is empty again. So now here we are. There are 2 amino acids there, right? This one is empty and this one has nothing, right? So this is the E site. So this one comes out. Now a new, whatever this 3 one is, a new one comes in with the tRNA, with the new amino acid, and then that's going to happen again and again and again until you get to stop codon. Once it gets to stop codon, this whole thing falls apart. Now you have this amino acid chain, however many it is. It might be 150 of them, however long the gene is, right? And now you have this chain, just a long chain of amino acids. It's not functional yet. It has to go ahead and fold. So it has to go through all this folding, right? So we start with the primary. We have the primary, which is just a long chain. And then we know this from first semester, beta-pleated sheets, alpha helices. Then it comes together, folds even more. And then quaternary is where all the subunits are put together and it's fully functional at that point. Okay. Now, what we're reading off of, we have this table. Okay. We're going to have this table on the test so you can see what is going on there. Okay. So the way this reads, there's a first letter, as you can see, that's your first. Then you have your second and you have your third, right? So if I say it's U, that would be phenylalanine. That's the amino acid right there. So it reads 3 at a time. This is the mRNA code, right? This is not what's on the tRNA. tRNA is the anticodon to that. And it's going to do that until it gets to one of these. Right here are your 3 stop codons. That's why you don't have to memorize them because they're already on the table. Here it tells you it's your start codon. That's your formylmethionine. Okay. And as you can see, this is what we were talking about last time as well, about mutations being silent, meaning your body is never even going to know it mutated. If, let's say, for example, right here we have, let's say, this amino acid, asparagine, okay? There are 2 sequences to it. So we can have AAU or AAC. Now, if the U and C switch places, for some reason there's a mutation where the U is replaced by C or vice versa, whatever happens, then you can still code for the same amino acid without a problem. Your body will never know that it mutated. That's called a silent mutation. There are other mutations, though, that can be really horrible. There are nonsense mutations where what if accidentally it mutates and you end up with a stop codon where it shouldn't be? That would be a very dysfunctional protein, right? That protein wouldn't be able to work at all. You have missense mutations. Those are if, let's say, instead of leucine, it ended up being proline. Because amino acids have different little side chains, they have different properties and different folding abilities. The minute you change it,